This is the first of some videos on sound and sinusoids. Now, if you haven't yet watched the YouTube video on the Rubens tube, I would suggest that you watch that first, because that will give you a really good visualization of sound as a sine wave. But I want to explain using another visualization about why sound can be represented by a sine wave. Here is a little animation of how a sound wave travels through a medium like air or water. So this gray line represents something that's vibrating. This could be your vocal cords, it could be a guitar string, it could be the head of a drum, it could be anything that makes a noise by vibrating. And when it vibrates, it pushes the air molecules into little ridges here so it kind of squishes them together, making an area of increased pressure here, and then as it moves back, then we have in between areas of decreased pressure. And these little kind of bunches of molecules travel together in these wave patterns, and then at the other end they hit your eardrum. So maybe on the other end there's a eardrum over here, and they're bouncing off the eardrum, and so as they bounce off in a certain frequency, and your ear recognizes that as some sort of a sound. So looking back at our notes here, you see that the increased pressure then can be thought of as the high point on your sine wave. If your sine wave is measuring the atmospheric pressure over a period of time, then this would be high pressure, low pressure, high pressure, low pressure, and it just follows the pattern of the waves. So that's why a sound wave can be represented with a sinusoidal function. Now, I want to show you another visualization of this. So we can look at I have a virtual oscilloscope here, and this oscilloscope is actually measuring what I'm saying as I talk. It's taking in my sound of my voice. So I'm going to attempt to make a more pure tone and show you that it looks like a sine wave. Okay, so that is what a sound wave looks like. It looks like a sine wave. Now I'm going to talk about what happens when I do loud versus soft, or low tones versus high tones. So let's try it first, loud versus soft. Notice what happens. The amplitude increases when I'm louder than when I'm very soft. Okay, the next thing I want to show you is high tones versus low tones. Okay, this is a fairly low note. Okay, so you can see the long period that represents this low note. Now let's try to do a higher pitch note. Now notice it has a higher amplitude. That's just because when I sing a higher note I have to make it louder to come out. But notice that the period here from here to here is shorter than it was when I did the low note. The low note, the period went clear from here to here, but this is a shorter period. Let me see if I can make it even higher. Okay, notice how the period has gotten much, much shorter than it was before when I sing a high note than when I sing a low note. So let's go ahead and put these in our notes as a more formal statement. So amplitude measures loudness. Okay, so we have something that is not very loud. This is a fairly soft sound. Okay, it has a very small amplitude. This would be something that makes a loud sound. It has a high amplitude. Now let's talk about high pitch versus low pitch. So pitch is like high pitch, low pitch. That's what pitch means. So when we want to do a low pitch has a very long period. It's a long period, which means it has a low frequency. Long period, low frequency. And that's because period and frequency are reciprocals of each other. Period is the number of seconds per cycle. In other words, how many seconds does it take for this particular sound wave to pass by? Whereas frequency is number of cycles per second. In other words, how many sound waves pass by in 1 second. Now, a low frequency then would be a low pitch for a note, something very deep. But if I have a lot of waves in a short amount of time like this is going to have a short period, which means it has high frequency. There are a lot of waves that pass by, or a lot of cycles per second. So this is going to be a high-pitched note. So a high pitch, like this, very high.